The following half reactions are combined in a galvanic cell. Write the net Ionic equation and determine the standard cell potential for the cell. Assume that all the concentrations are 1 mole per liter and all the partial pressures are 1 atm. It means that we are dealing with standard situation. So we need to write the net Ionic equation and we need to determine the standard cell potential. Let's start with standard cell potential. The formula for finding standard cell potential is like that. So equals to standard reduction potential for cathode minus standard reduction potential of anode. So then we need to figure out which reaction is cathode, which reaction is gonna happen in anode. Cathode is where reduction occurs and anode where oxidation occurs. Cathode is the one that is stronger oxidizing agent. It means that in the table, in standard reduction potential table, this one must be on top of this one. So when we compare these two, 1.36 is greater than 1.09. It means that chlorine is stronger oxidizing agent comparing to bromine. So chlorine is going to be the oxidizing agent, which reduction happens, and bromine is going to be reducing agent, which oxidation happens. So it is going to be 1.36 minus 1.09. That's going to be 0.27 volt. That's the standard cell potential. Now let's focus on net Ionic equation. So this one is reduction, so we keep it like that. But we need to write the second reaction on the other way in order to be able to cancel the electrons. So it's going to be 2 Br minus gives us Br2 plus 2 electrons. And when you add them, these two cancel out. We have Cl2 plus 2 Br minus gives us Br2 plus 2 Cl minus. That's the balanced reaction and it's net Ionic equation for these two half reactions.